All right, so warm up 120. Compute the measures of variation, sketch the bell curve, and compute the z-score of 25. So share with your neighbor what you got for that, and then I'm going to have Jaden get us started to see what we got. And today we're going to be moving on in regards to our z-scores and all that, because we do need all of this. And I just want to make sure that that we got plenty of practice. I'm pretty sure, because I think I've been giving you plenty of practice on the warm-ups. Is that correct? Yes, Mr. Q. All right, good. So let me set this up. So measures of variation, what are they? Jaden. Standard deviation. Hold on. Standard deviation. What else? Variance. And range. All right. So far, so good. So what'd you get for the range, Jaden? What is it? 35. Hands, have you got that? All right. We need a variance. Pass someone. Jaden. Fernando, variance. $145.13. Hands, have we got something like that? Plus minus like 1 or something like that? Yeah. Standard deviation, pass someone. Areli. 12.04. Okay. So, and we need a mean. Pass someone. What is it? For the mean? $20.83. Okay, that looks about right. So one standard deviation up, we should be at 32.87. And one standard deviation down, we should be at 8.79, something like that. Yep. All right. So, brings us to the z-score. Share with your neighbor what you got for the z-score. All right, good conversation. Pass someone, Diego. Jaden. You can get the z-score. So the formula is x minus the mean, is that correct? Over standard deviation, okay. So, pass someone. Me? All right. Joseph, what you get? 0.34? 34. So 0 is here at the center where the mean is at. And if it's a positive, I'm pretty sure you went up to the right. 0.34 is 1/3 of the way, so about right here. So that's our z-score. Hands, if you got something like that. All right, good. Because today we're going to be using all of this, guys. I'm just giving you a heads up because we're moving on to the last section of the course. Copy the warm-up, please. Make sure you send me the warm-up on Nearpod. Warm-up 120, normal distribution. Tonight's home plate, only 10 problems. Only 10. All right. So, home plate code L95ZC. 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 Now, I can probably say that this last section is going to be what's the word? Oh, my word. Tweezy. You guys like that word? Tweezy? Because we already did all the work throughout the school year. I'm just putting it together with one last portion that we need. All right? Your home plate is going to look something like this. So you have the code. All right, get a Cornell note ready. I can define and compute the normal distribution. I can define and compute the normal distribution. Normal distribution. All right, so normal distribution, I'm not going to give you a Frayer model for that since we've already been looking at it all year. But where have we been? So far, we've been talking about probability. And in regards to the different probabilities, we talked about variables. And we said discrete and continuous. So remind your neighbor between discrete and continuous. What's the difference from one to the other? Discrete and continuous. All right, looks like Arely's got it. Very good, Arely. Lenny's got it. Very good, Lenny. All right. So, discrete is a finite number of possibilities, and continuous has all kinds of possibilities. All right, so we focused a long time on discrete variables and probability. And I said in order to move on to the last section, which is still on variables, today we're going to focus on continuous. Continuous, which implies that we're going to be looking at various probabilities or values, which encompass everything. And today we're going to look at it under the lens of the normal curve. So look up to the screen. So we got something called normal distribution, which is a normal bell curve. There it is. Copy that. This is what we call a normal distribution, normal bell curve. We have the mean going straight down the middle, and that's what makes it symmetrical on both sides. That's what we call a normal distribution. On the left side, copy this one. This one's called skewed left, which means it moves all the values to the left, including the mean. You see the mean, how it moves to the left, median mode, all that's to the left. So if there's such a thing as skewed left, there has to be such a thing as what? Yeah, skewed right. There it is. All values move to the right. Copy that. All right. So you have the code in case you fall behind on the notes. You have this presentation with that code that you wrote down. So I'm going to focus today on symmetrical or a normal distribution, which is this one. So if you want to add more to this curve that you already made, oh my bad, let it go. We're going to focus on symmetrical or normal curve. So we're going to add percentages to this, and we covered this at the beginning of the school year. Let's see if you remember. You guys remember those percentages? Yes? So add that to your normal curve, please. The mean, or mu, is down the middle. One standard deviation from the mean, it's at 68.26%. And by now you guys are experts at that because we always continue saying that this was the norm. Two standard deviations apart is 95.44%. And three standard deviations apart, that's 99.72%. So here's a question. Look up, please. If between the three standard deviations is 99.72, second neighbor, what is the percent under the entire curve? What is the percentage under the entire curve? Percentage under the entire curve. What do you think, Mia Victoria? Total percentage under the entire curve. That is correct, 100% under the entire curve. Because from the third standard deviation to the other one is 99.72, but we still need the little bit piece on this side and on the left side that makes up the 100%. Okay? So keep that in mind, that under the curve is how much, everyone? 100. All right, good. 100 under the curve. 100. Okay, we good? Yeah? All right. So today, we're going to be using our z-score in order to find percentages under the curve according to that score, whatever that score may be. Okay? Everybody copy this? Yes? Yes, Mr. Q? All right. All right. So normal distribution, we're good, yes? All right. So once again, 68.26 splits the middle to 34 and 34. So if from here to here is 95.44, it splits this into 13 and 13. Fill that in, please. And if from the third deviation to third deviation, that makes up 2.14, 2.14. And if you notice, if you start adding all these up, that should add up to 99.72. Oops, sorry. So, before we move on, just to make sure that we understand what we're looking at, here's mu. Look up. Here's mu. So if I was to ask you what is the percentage of any score under the curve before mu, tell your neighbor what that is. What is the percentage before mu? All right, what do you think, Briseida? %. That is correct, because if this is symmetrical, this cuts it down the middle. That means this is 50%, and all to the right is 50%. That is correct, and so on and so forth. Okay, so with that said, by now we are experts at z-score, but just in case you missed it, once again, you find the z-score by x minus the mean over standard deviation of the sample, or in regards to population. Okay? So, here's a table we're going to be using today to translate z-scores into percentages. You're like, oh snap. No, it's easy. So if you notice, I divvy the data into two sections, the one on the left, the one on the right. So look up, very important, so you know exactly what we're looking at. Right now when I send the table to your screen, you're going to know that if you split this down the middle, this is our mu, which means all of these are what? Kind of these. They are negative. That means that all of these are what? Positive. So far so good, yes? All right. I'll send that to you in a little bit. Let me send that to your screen. Hold on. So here we go. Look up to the screen. I'm going to show you how to use this according to the warm-up that we just did. According to the warm-up, Joseph said that the z-score was what? Point what? 34. Is that correct? Yes? My bad. There it is. The z-score was what? 0.34. And it was what? Positive. So, let's go to our table here. Which ones are the positives? The ones on the right, yes? So we first start, look up here where you see the z. You guys see it? Then look for 0.3. Where's 0.3? 0.3 is right here. But the z-score was what? 0.30 what? 4. So that means we need 0.4. Is that correct? So go to the top. Look for 0.4, which is here. So put those two together. They match up right here. What is that number, everyone? Let me zoom in. That number is 0.6331. This is a percent. So tell your neighbor what this percent converts to. This becomes what? Yeah, 63.31%. So what does that mean, Mr. Q? Well, let me zoom out. Look up. That means that if we read this graph from left to right, all the way to the z-score, all of this, look up, from here to here, that z-score is going to give me a percent, which is 63 point what? 31? 31%. Label that on your warm-up, 63.31%, and shade everything to the left of the z-score. So once again, everything from the z-score to the left, we looked it over in our graph. We got 0.34. It gave us 0.6331, made that into a percentage, which is 63.31%. Okay. Everybody with me so far? Okay. So that's everything to the left. Tell your neighbor the percentage of everything to the right of the z-score. Talk it over to your neighbor. What would be the percentage of everything to the right? How can we get that? Everything to the right of the z-score. Then we're going to ask Caleb to enlighten us. Everything to the right of the z-score. How do we get that? Caleb. Let's go. Subtract from 100. Man, Caleb, let's go. Subtract that, and that gives us 36.69%, which is the blue part. From 1 to 5, I'll control you with this. 5 fourths, okay. That's pretty much the home plate, by the way. So, with that said, let's get some practice in. Copy this one, please, on your paper. Example 1. Find the area to the left of Z 2.06. I'm going to leave the table on your screen so you can use that. So copy this on your paper, then draw me a bell curve. And it says here 2.06. What does this mean? Talk it over to your neighbor. What does this mean? Caleb, pass someone. What does that mean? Jaden Montes? What does a 2.06 mean? That is how many standard deviations? At least what? Yeah. Yeah, at the right side of the mean, at least 2 standard deviations and a little bit more. So that z-score is 1, 2 standard deviations, 0.06. So very close to here to the second standard deviation. So that is that. But they want the area to the left of the z-score. All right? Show your neighbor how you're using that table to see if they find the same thing as you. And then find me the percent. All right, first I want a decimal. Pass someone, Jaden. Dylan, what best decimal did you get? Oh, David. Oh, my bad. David's not here, so let's pass it to Dylan. Dylan, what decimal did you get with that? Okay, let me go back to the table. Okay, so it's a positive. So we look at Z. Here's Z. Start with 2. Where's 2? 2.0 is right here. what was it, 2 point what? 06. So first is 2.0. 2.0 is right here. 06 is right here. So these two meet up about right here. What's that number? Let's see. Well, 98.03, yes? All right. So, let me go back to this. Oh. So the z-score was 0.9803, is that correct? Yes? So what is that percent, everyone? %98.03%. Okay. So that's everything to the what? To the left. But what if I ask you for everything to the right? What is that percent? Everything to the right. So you never what to do for that, and give me that percent. All right, Dylan, pass on one. Mia Victoria. You get 1.97. Hands if you got that. Looks about right. And how do we get that? Well, 93 you take away from 100, and that's how we get the 1.97. Okay? From 1 to 5, I'll come to you with that. 1 to 5, 5, 5, 5, okay? Send me your notes, give me seconds. One more, copy this one, example number 2. Find the area to the left of z, negative 1.67. Z, negative 1.67. So once again, make sure you draw your bell curve, sketch where z is at, and then shade everything to the left. All right, I think we got it. Let's see. Here's my bell curve, the mean, and the mu, and then let's see, 1 standard deviation, 2 standard deviation, 3 standard deviation. So 1, 2. So negative 1.67 is negative 1.67 is about right here, almost close to the 2. So you're looking at everything to the left of that. So, who went last? Mia Victoria. Pass someone. What is the percent under that curve? Who? Peyton. What you get, Peyton? I can't hear with the AC. .36%. Hands, have you got that? I sense a disturbance in the force. What you get, Lenny? 56? Okay, let's double check just to make sure. Let's see. Negative 1.67. Let's see. We got negative 1.6 right here. Yes? And then we start at 0, 0. Okay, so we need 0, 7. So let's see. 0, 0, 0, 1, 2, 3, 4, 5, 6, 7. Hands if you got that. Yeah. So be careful with these. Like I said, start with the negative 1 point or whatever they're giving you for the z, Then just find the other decimal, the second decimal, as you go to the right. So, going back to our problem, let me zoom out. So instead of 56.36, the decimal was what? 0.40 what? 0.0475. So that means that percentage under the curve is 4.75%. Yes, no, maybe so. From 1 to 5, how comfortable are you with that? All right. So, one last one for the sake of practice here. Not that one, not that one. Let's try this one. Find the area between Z168 and negative 1.37. You're like, oh snap. Oh snap is right. So first, negative 1.68, negative 1.6, so it's 2/3 of the way, so it's about right here. So this one is this one. Everything to the left. However, they want everything between that one and negative 137. Negative 137. Negative 137 is negative 1, and 1/3 is about right here. So, between. So that means from here to here. So, who can give me a decimal for 1.68 of Z? 1.68. Peyton, pass them one. Daisy, give us the decimal for 1.68. Oh, you did the negative 1.37? Okay, what'd you get for that one? 0.0853. Okay, hands, have you got that for that one? All right, how about for the 1.68? How about, who haven't we called on in a while? Jaden. 0.9535. Hands, have you got that? Okay. So, how would we get this area right here in between those two? What do you think, Jaden? What would we do? So this would be 95.3%, okay? And this one would be 8.5%. I'm just averaging, okay? And then? You would subtract what? So you would subtract what? 50 from that? Okay. What did you do, Illy? Okay. So here it goes, guys. Do we know the percentage from left to right all the way to the red Z? Yes? So that means we only need to take away what from all that? This, is that correct? So how do we take that piece away? Kendall? Uh, 98. So everything to the left of the negative is 8.5, and this is 98, and subtract, so 95.3, subtract 8.5, and that should give us our total percent, which is what? 80, what? 86 point what? 82%. Hands, have you got something like that? Yeah, that is correct. Woo-wee. You're like, oh, snap. Okay, I see it. You guys see it already? Yes? All right. So, with that said, your home plate for tonight, I'm going to stop right there, is that one. You have the code. Those of you following online, make sure you get in some practice and enjoy. Bye.